Now that we've learned how to divide the polynomials by monomials, what we're looking at today is one of our first ways of being able to factor these things. And so the first way I'm going to show you to factor is by pulling out a GCF. So I've given you some steps in the green box right here to help you out with how to factor by pulling out a GCF. And so the first step that I've given you is to look at all the terms in the problem and to figure out what the GCF is for all of those. And so it's going to be a mix of numbers, which we call coefficients, so the numbers that are right in front of a letter. So if I had like 6x squared, 6 would be the coefficient. So numbers that are right in front of variables, we call those coefficients. So we are going to have coefficients, and we're also going to have a mix of variables with exponents. And so basically what you would do is you'd figure out what the GCF is. For numbers, you would just look at the numbers and figure out what the GCF is among the numbers. And then for exponents, what you would do is look at things that have the same variables, and you want to take the least amount of exponents they have in common. Or you want to take, I'll show you an example. That was a little misleading. But let's just go step by step for 1 through 4, and I will show you what I mean. Okay, so looking at our number 1 here in the pink, I have 15m squared minus 9. And so the first thing we want to do, so here's a term, the 15m squared is a term, and the 9 is a term. So looking just at the numbers, what is the GCF between 15 and 9? The GCF between those two guys is 3. Okay, so if you don't believe me, if you still need to go and make your factor trees, that's fine. So here's 15 and 9. So there's no 5 they have in common, so I can't circle it, but they both have a 3 in common, so their GCF is 3. Okay, and what you want to do now is we're going to fuse what we did yesterday and do this. So I'm going to write each of these terms, 15m squared minus 9, and I'm going to divide it by our GCF. So in this case, our GCF is 3. And so if I divide this, I end up getting 5m squared minus 3. So I've done, find the GCF, I did that already. I divided the exponents. I've divided the coefficients of each term with the GCF and subtracted the exponents. In this case, there was nothing to subtract because the m squared had to drop down since there was nothing to cancel it out with. Now I'm on step 3. So after I've completed step 2, what I'm going to do is I'm going to write my answer in parentheses. Step 4, put the GCF, which is 3, outside the parentheses, and there's our final answer. Okay. So the way you can check to make sure you've factored it out correctly is if you distributed this 3 back in, you should end up back at the original problem. So if I distributed the 3, I'd get 15m squared minus 9, which is the original problem, so I know this is correct. So that's the way you can check your answer, is by distributing your GCF back into the parenthesis. Okay. Let's look at number 2. So first thing we need to do is we need to figure out our GCF. So let's figure out our GCF between all the numbers. So between 28, 12, and 20. Okay, so between those guys, their GCF, if you had to make your tree, go ahead, but their GCF is 4. Okay, now what I notice is that all of these terms have an a, so my GCF has to have an a variable in it. And the way you figure out what the exponent is you look at the smallest one. So I have 5, 3, and 2. The smallest exponent is 2. So that's the GCF there. Okay, and we repeat. We rewrite everything. It should be 28, sorry. So we have 28, a to the 5th, minus 12a to the 3rd, plus 20a squared. And I divide it by our GCF, which is 4a squared. Simplify each of these little fractions that we have, and I end up with 7a to the 3rd, 3a, and 5. Okay, put that in a parenthesis, write my GCF on the outside, and there we go. Again, if you want to check your answer, all you have to do is take this guy on the outside and distribute him back in. So I'll do it really lightly here on the bottom, so I get 28 a to the 5th minus 12 a to the 3rd plus 20a squared. And oh, I got the same thing as the beginning answer, as the beginning problem, so this has to be correct. Okay, so that's how you would check for there. Let's try a few more. So another short lesson today, just 4 problems here. And let's look for this, okay? Factor this out. So here's my numbers. Okay. So out of these two guys, my GCF for the coefficients definitely is 5. Okay. Looking at the x's, I have x to the 3rd and x squared. So you want to take the smaller out of the bunch, which is 2. And again, for the variables, each of the terms have to have the same variables. So I can pick x and x because there's x's on both of these. There's y's on both of these. There's z's on both of these. Whereas in number 2, or in number 1, we couldn't pick an m. M couldn't be part of our GCF because the 9 didn't have an m. Okay, so in 22, all of the terms had an a, so we could have an a there. But in number 1, they don't all have an m, so we can't include it. Okay. Anyways, so going back here to number 3, the y's, I can have a y. My smallest exponent would just be this 1 y, so that's it. Z has to be just z because this is z squared, that's regular z, so my GCF for this is 5x squared yz. Okay, so you take the smallest exponent out of the two. To do this, to finish this off, you just rewrite the problem. And then you're going to divide everything by the GCF. Okay, so I end up with, in this first term, 3. I have an 1x left over, I have a y left over, and then my z's cancel out. Minus 20 divided by 5 is 4. X squares are going to cancel, y's are going to cancel, and I'm just left with a z. Put that answer in a parenthesis, put my GCF on the outside. And there we go. Okay, so let's check. So if I distribute that in, I get 15 x to the 3rd y squared z minus 20 x squared y z squared. And go and check, and they both match up, so this is a good answer. Okay, now let's try this number 4. So let's pick out the GCF. So for all the coefficients, 21, 7, and 14, the number they have in common, the biggest number they have in common is 7. Okay, looking at the m's, can I include the m in my GCF? I cannot, okay? I have an m here, I have an m here, but since there's no m here, m cannot be included in my GCF. But I can include n, so, because I have an n, so we're good. But looking at this, all my n's are just regular n's, so I don't even have to worry about figuring what the exponent is or any of that business. So my GCF is 7n. That's what it is. And so to finish this out, all I'm going to do is, again, rewrite the original problem and then divide by my GCF. So I end up with 3 m to the 3rd, my n's cancel out, minus 7 cancels out, m squared stays, n's cancel out. Then I get plus 2, and then the n's cancel out. Put that guy in a parenthesis, rewrite my GCF, and final answer. And if you want to check, let's redistribute. 21 m to the 3rd n minus 7m squared n plus 14n. And yep, get back to the final answer, so that is good. Alright, so don't forget to take the quiz, write down questions, anything you might need from me, okay?